Welcome to our presentation on supporting NGOs to fight child mortality through the development of a data visualization web application. This presentation was prepared by Eduard Jackman, Martin Meyer, Nikola Mikolashkova, Jordan Perryman, and Nicholas Rizal as part of the Applied Software Engineering module. We begin the presentation by introducing our problem statement and discussing the project's goals and objectives. Then, we define the application requirements, which have been modeled using user stories and prioritized using the planning poker method. Moreover, we visualize the interactions between users, in our case NGOs and donors, and the system with the help of a use case diagram, as well as explaining two of the use cases in greater detail. Moving on to the design section of the presentation, we present our UML class diagram, wireframes, and entity relationships diagram. Next, we introduce the World Health Organization's child mortality dataset, reflecting upon its quality and key attributes. Furthermore, we discuss the questions the team aims to answer through the data and explore the data cleaning methods used. Finally, we move on to explain the development implementation approach selected, namely the Team Data Science Process, or TDSP method, and how we planned the testing phases. Child mortality rates have been decreasing at a remarkable pace. According to UNICEF, the annual reduction rate has increased from 1.9% in 1990 to 1999 to 3.7% in 2000 to 2019 for under 5s. Nonetheless, the improvement of child mortality remains to be a matter of great international significance. In 2019 alone, over 5 million children under the age of 5 died from mostly preventable or treatable causes, as reported by the World Health Organization. Various NGOs are delivering foreign aid to the worst affected regions. Smaller charities tend to focus on only one or two causes of high child mortality levels, such as malaria or HIV. Examples include charities like Network Against Malaria or AIDS Orphan. Firstly, these organizations often lack the resources and technical expertise to identify the regions and age groups most affected by the causes they focus on, thereby making the delivery of targeted foreign aid challenging. Secondly, they find it hard to measure the impact they make on reducing child mortality rates from certain causes over time. Impact measurement is instrumental for demonstrating their positive contributions to stakeholders and donors of the organization. Finally, they struggle to obtain continuous funding for their organization, jeopardizing its survival. Therefore, there is an opportunity to support smaller NGOs in decreasing child mortality rates by providing a relevant and easily accessible data visualization and fundraising tool. We identified our project goals based on these three challenges. Firstly, we aim to help small NGOs identify the regions worst hit by high child mortality rates. Secondly, we want to help small NGOs monitor and measure the impact their operations have on certain causes of child mortality. Finally, we intend to help small NGOs connect with more donors. To determine the project objectives, we use the SMART template, which helps us generate specific, measurable, achievable, relevant, and time-bound targets. Hence, this method contributes to staying focused on what needs to be put in place and how we can achieve the project goals. We set ourselves 10 SMART objectives for this project. One example for these is that by the 1st of February, unit testing relating to the code will be fully completed. Moreover, another example is that by the 30th of March, system testing relating to the code will be completed by 50%. The Lincoln Index will be used to estimate the number of bugs in the system. To empathize with our users and develop a better application for their needs and requirements, we created various user stories. This technique helped us to provide context for our website, hence giving us insight into how we should be developing this application to maximize value for NGOs in the future. We decided to use the planning poker method, which is a consensus-based gamified technique for prioritizing these user stories. We first ranked the user stories individually to avoid being influenced by our teammates. Then, we had the opportunity to discuss the outcomes and refine our prioritization. Thanks to the planning poker method, we were able to find the 5 most important user stories, helping us to determine the core functionality of our application. While user stories 6 to 8 were also included in the application, we decided not to take into account the 2 stories deemed least important. Now, we explore the 5 most important stories in greater depth, highlighting their conditions of satisfaction. Our first user story is about providing a heat map for each cause, such that NGOs can identify the regions where the delivery of foreign aid should be prioritized. Our second one focuses on the change in child mortality rates over time in the regions they deliver aid, enabling NGOs to measure their impact. The third story focuses on the identification of highly affected age groups that have not been receiving sufficient support by displaying how mortality rates are changing in each age group. The fourth is about enabling donors to support relevant NGOs through a donation portal. Finally, our last story focuses on the other side of the previous story, that is, on providing a new fundraising channel for NGOs. For this reason, these 2 stories have the same conditions of satisfaction. Moving on to use cases, we have selected 2 of our most important ones. one of which we cover here, namely login. For the rest of the use cases, please refer to the appendix. The login use case enables users to log into their account or sign up if they do not have one. Its primary actors are NGOs and donors, and its precondition is that users must have navigated to our website. The main flow has 3 steps. Firstly, the use case starts by loading the login page. Secondly, users select the sign in button. Finally, they enter their username and password. The post-condition is that users are redirected to select option. The alternative flow is that users select the sign up page and are redirected. We created a use case diagram which visualizes the interactions between the system and users. It shows our actors, NGOs and donors, the boundary of the system, our 10 use cases, and communication links. We used a UML class diagram to visualize our classes alongside their attributes and methods as well as the relationships among them. Our application has 6 classes. These are account, user, selection, donation, filter data, and plot. Each user can have 0 or 1 account, and each account has exactly 1 user. The user creates the account using the createAccount method. Selection is a class that enables users to navigate within the app, in particular to select the disease they would like to view and or the company they would like to donate to. The donation class allows users to make donations. It uses the setAmount method to specify a donation amount and donate to initiate the payment process. The filter data class prepares the dataset for visualizations by filtering it appropriately to the user selection. The class plot uses the filtered data to create visualizations, including heat maps and bar plots. While the setPlotType method allows for selecting the type of plot to be visualized, the plot method actually creates the visualization. The next stage of our design process was developing a wireframe. We first started with hand-drawn wireframes, enabling the team to iterate over the functionalities of the web app. Once the final version was completed, we used Adobe XD to digitalize the wireframe. We'll go over 4 sections of the wireframe that show the various functionalities of the app. Firstly, we'll present the sign up and login section. This is the login page for our web app. Here, users can either log in using their credentials or sign up to join our platform. To sign up, users will need to create a username and set their password, as well as provide their nationality and address. In case the user represents an organization, the checkbox can be selected. Next, the user would need to input the name of the organization they belong to. Finally, they will be redirected to the login page where they can use their newly created credentials to log in. Secondly, we'll present the data visualization section. From the main menu, the user can tap to explore the various death causes for which information is available. The Explore More button will redirect the user to a page with the first visualization. The heat map of the world colors each country depending on the current number of child mortality cases due to the chosen cause. When hovering over a country, users will get a snapshot of the information available for that country and a More Data button. Once clicked, users will have an interactive decision to be made, filtering the data by age or by year. If by age is selected, users will be shown a bar plot with the number of deaths by age group in a specific year. The year variable can be changed using a slider to show changes in the number of deaths over time. From each visualization page, users can navigate to the other visualization, in this case the year visualization. Here, users will be shown a line plot that aims to show the underlying pattern of child mortality cases over 4 time periods. Thirdly, we'll present the donation section. From the main menu, users can select the Donate button in the top menu. This will redirect them to the main donation page. Here, users can explore the different NGOs available for donation, select their organization of interest, and make a donation. Finally, we'll present the Profile and Logout section. Once again, from the main menu, users can open their profile where they can find all their personal details, ranging from address to account password. Moreover, users can delete their account and log out of the platform from this page. Now, we move to the database design. On this slide, you can see an entity relationships diagram, which is the result of the combined conceptual and logical stages of database design. This diagram includes several entities, which in our case are account, donation, country, disease, and address. Each entity also includes several attributes, their data types and any constraints, and also identifies primary and foreign keys. For example, the primary key address ID in the address entity is used as a foreign key in the account entity to monitor where our users come from, and also in the donation entity to serve as the billing address. The dataset we will be using for this project is the World Health Organization's number of deaths in children aged under 5 by cause. This dataset shows the number of deaths in children under the age of 5, split into 3 categories: 0 to 27 days, 1 to 59 months, and 0 to 4 years. These values are recorded between the years 2000 and 2017. It also includes the geographical data about location, i.e. different countries, and it differentiates between different causes of death. On the slide, you can see the screenshot of the dataset as shown on the World Health Organization's website. On this slide, you can see the downloaded dataset in the format of an Excel workbook file. The columns we will be using are the following: location, which represents the country, DIM2, which represents the cause of death, period, which represents the year, DIM1, which represents the age group, and fact value for measure, which represents the actual number of deaths. The dataset also includes some other columns, but these will not be necessary for our analysis, so we will exclude them. With this dataset, we aim to answer the questions which you can see on the slides. By answering these questions, we hope to help NGOs or individual users who use our app to clearly see what countries are the most affected in terms of child mortality. This will help them know how to target the most affected countries, and in doing so, efficiently use their money on donations to those who need it most. There are some limitations to the dataset we will be using. Namely, there is some duplicate data in different columns. Some NAs are present, some numeric data is stored as text, and some outliers might be present. You can see how we plan to address these issues in the table on the slide. For this project, we want to use the Team Data Science Process, or TDSP, software development method for several reasons. TDSP focuses on easing team collaboration through the standardization of the project structure. This allows for more efficient and understandable collaboration, as well as helping with the challenge of remote pair programming. Since the code and documentation are available for everyone to see and edit, teammates working remotely can still participate in the development of the project. Also, the emphasis for incremental deliverables is particularly useful given the need for constant testing and weekly meetings with the TA. Finally, selecting roles within the team, as recommended by TDSP, leads to a more efficient development process. The roles ensure that each requirement of the project is being met while efficiently dividing the project into more manageable tasks instead of multitasking. On this slide, you can see the overview of our plan of testing of the app. We have split this plan into three main parts, first of which is debugging. While we plan to use different techniques for debugging, our main focus is the Lincoln Index, consistent with the SMART objectives. Furthermore, we focus mostly on development testing and some components of release testing, as user testing is not applicable for our project. Finally, on the right side of the slide, you can see examples of unit testing of some of our functions that we wish to carry out. Finally, on this slide, you can see what parts of the project each member of the team worked on. This concludes our presentation. Thank you for your attention. The following appendix shows more examples of the use cases that we worked on, which were not included in the main body of the presentation, as well as our sources.